Thank everybody for joining our webinar today. We're going to wait about 60 seconds here as people continue to join, and then we will get started. All right, I want to thank everyone for joining our session today, which is titled The Small Cell Scale Problem: How Do We Get to Ultra-Dense Networks? My name is Zhan Kinney. I'm the Editor-in-Chief with RCR Wireless News. Just some quick housekeeping notes. We will make a video recording of this webinar available when we finish up today. The slides will be available for download, and registrants will receive a companion report that goes into a little more detail on the topic. And we've got time allocated at the end of the session to answer questions, so please use the webinar portal to submit your questions throughout the discussion, and we'll try to get to as many as possible. Before I provide a little context on the subject, I'd like to welcome our panelists from Airspan Networks. We're joined by Damiano Coletti, who's the Vice President of Strategy and Marketing, and Hongtao Zhan, who's the President and CEO of SureCall. So thank you, gentlemen, for joining our discussion today. Next slide, please. So first off, let's take a look at some small cell deployment figures. These numbers were put together by the Small Cell Forum. I know there's a lot going on in this graphic, but what I'd really like to call out are the trends we see around what the Small Cell Forum categorizes as urban public small cells, which are what operators around the world are deploying outdoors, and then public and private enterprise small cells, which are being used to improve in-building cellular quality. What you see here is relatively consistent increases in deployment numbers starting in 2015 and projected forward to 2025. That time frame is in sync with both operator network densification investments for LTE networks, and that's necessary to create a high quality network surround for 5G, which is also dependent on major densification investments. On the enterprise side, operators reserve their in-building CapEx for what I'll call marquee venues like stadiums, transit hubs, and so forth, and in some cases for Class A commercial real estate or very high-value customers. What that means is there are a lot of buildings that don't have in-building systems. They're not going to get them from operators, so the impetus to invest in an in-building system is put on the building owner or the tenant. Next slide, please. So I alluded to a little bit of this, but why do we need ultra-dense networks? At a high level, it's because the demand for mobile data is growing at a fantastic rate, and it'll be absolutely necessary to ensure that 5G lives up to the hype. To the data usage point, Ericsson's research projects a 10x increase in that 6-year period ending in 2022. To the 5G point, millimeter wave frequencies are how you're going to deliver these multiple gigabit per second throughputs. But millimeter wave bands, it just doesn't travel very far. So that means you need to increase your node density. In the US, Verizon's launched a limited fixed wireless 5G service using the 28 gigahertz band. That'll be followed by mobility. AT&T is working to launch mobile 5G in 12 markets by the end of the year using the 39 gigahertz band. At the same time, both of these operators are investing heavily in gigabit LTE networks based on the LTE advanced standard. So on the tech side, that means multi-channel carrier aggregation, license-assisted access, which aggregates licensed and unlicensed frequencies, 256 QAM, and 4x4 MIMO. This is important because early 5G deployments will be geographically limited. So as users move in and out of 5G areas, they need to have a high quality LTE network to fall back on so that there's a continuity in the user experience. And then another key aspect of 5G is significant reductions in latency. You need this to support consumer applications like mobile AR and VR, gaming, and for anything autonomous, really, cars, drones, industrial equipment, and so forth. To reduce that latency, you've got to put your network infrastructure closer to the end user. That's just a function of physics. And this discussion around mobile edge computing is also a key piece of that, but that's for a different webinar. Next slide, please. So that's why operators need to densify their networks, and these are some of the challenges. This is pretty simple, really. Power backhaul, site acquisition. So not to be overly reductive, but if your goal is to deploy more small cells, in order to do that, you need a place to put them, a way to get power to them, and a way for them to connect back to the core network. Next slide, please. Another big challenge here is on the regulatory side. If you're an operator, you want a replicable deployment process that gives you clear costs and timelines. But this is inherently not a replicable process because every town in the country has different applicable regulations around planning, zoning, and that type of thing. You've also got a lot of existing franchise and pole attach agreements that can limit your ability to access a site, whether that's a pole, a traffic light, a rooftop, or some other type of vertical asset. Recently, the FCC took some action on this, essentially taking away a lot of the power municipalities have related to wireless infrastructure deployment. Some of the key pieces of that FCC order are establishing a uniform fee structure related to the review by city staff of permits and siting applications. And another aspect essentially sets a shot clock on the review period. So the point is to use these regulations to make this a more scalable process. It's worth noting that this order was handed down earlier this month, and there's already a number of city leaders around the country who are immediately pushing back on this because it, forces them to cede some autonomy to the FCC. So the FCC has passed this change, but given the dynamic that's shaping up, I'd expect there will be some challenges in the future. Next slide. So aside from the regulatory piece, how else are operators driving density? One of the newer models is this public-private partnership approach. To give you a little color on that, AT&T recently struck a deal with the city of Los Angeles. At a high level, AT&T is going to provide some smart city type services like traffic management, public safety, disaster preparedness, and so forth. And the city is going to give AT&T access to sites that will let them densify their network more quickly. Verizon's doing something very similar. They used Sacramento as a test bed of sorts, and they're now replicating that model in other places. It's same thing, really. The city wants services that Verizon can provide. Verizon wants access to sites and friendly regulations. So that's your value exchange. Another way to make this process easier and more scalable is to have a broad range of small cells that match your different deployment scenarios. So if you can access aerial cables, you want a strand-mounted unit. If you can get on a traffic light, you want something that blends right in and fits up against the pole. Same thing if it's a utility pole. If it's a rooftop, you need an option for that. So if something's going to be down at street level, you want it to blend in so that you don't get into a protracted back and forth with the city around aesthetics. There's all kinds of ways to do that. You can take reflective tape and put it around the unit to make it kind of mirror the surroundings. You can put these things inside streetlights, garbage cans, other type of street furniture. I've even seen pictures of one out in Arizona that looks like a cactus. So the point is having the right type of small cell and the right concealment solution can really help you deploy more quickly. Another trend we're seeing right now is CRAN deployments. In this case, the C stands for centralized. It's when you have access to a telco room or a co-location facility, so you put your baseband resources there in one location and then feed that signal out over a front haul link to remote radios. This can lower your CapEx, accelerate deployment, and centralized management of multiple radio sites opens up some inter-site coordination that can improve your network and spectral efficiency. Next slide, please. So I focused most of my comments here on outdoor small cells, but small cells also have a lot to offer to the in-building segment. I'm going to discuss this very briefly, and you're going to hear more about this from our panelists. But for in-building, your options are a distributed antenna system, a small cell system, some kind of hybrid of those two, or a signal booster, which takes a signal from the outdoor macro layer and brings it into the building. There's cost and benefits to all of these, but basically DAS is the most expensive of these options. For small cells, you see some limitations around multi-carrier support. And for signal boosters, if the outdoor signal quality isn't great, that'll be reflected once you bring it inside. So I mentioned earlier that operators don't really invest in in-building systems, save for some very specific scenarios. So that means building and enterprise owners have to foot the bill for these systems. Because this is a huge addressable market, you see this move from infrastructure vendors to take cost out of their equipment to the extent possible and to take complexity out of it so that technology can be managed more easily and just be more approachable for an enterprise owner. So I did a lot of talking there. I think now I'm going to turn it over to Damiano from Airspan to share his perspective and give you an idea of how their company is helping operators densify their networks.
Thank you, Sean. So good afternoon, everybody. Happy to be with you today and discuss a little bit about what Airspan brings to the market in terms of small cells, and touch on some of the points that Sean exhaustively mentioned just now. So next slide, please. So Airspan has been around for 20 years developing wireless products. We've started out in the WiMAX days and pivoted into LTE and doubled down on small cells in 2009 with LTE, and have continued to grow over the last few years with marquee deployments with tier 1 operators across the globe, most notably in the United States with Sprint. Next slide. So what is our competitive advantage? We have, as I mentioned, 20 years of proven technology in experience in developing radio solutions, but we also have very, very strong partners. Foxconn and Qualcomm provide both the manufacturing and the system on a chip and technology feature set that goes into our products. And as Sean mentioned quite rightly, form factor is a key component to addressing the barriers to entry of small cells, and we do this both in our indoor products and our outdoor products, be they pole-mounted, strand-mounted, or indoor enterprise solutions. And all of these solutions have very sophisticated plug-and-play self-optimizing network algorithms that allow these base stations to be basically blanketed and deployed en masse with essentially just the use of a FedEx truck. In the case of indoor, and in the case of outdoor with simply connecting power, leveraging multiple backhaul technologies, be they LTE relay, millimeter wave, fiber, or what have you. So we kind of address all of the pain points that Sean mentioned. Next slide, please. So this year has been a great year for Airspan. We've won multiple awards. Actually, there's 2 more which aren't on this slide, but most notably the GLOMO for Best Mobile Breakthrough Technology. And that's in recognition of our work with Sprint for the Magic Box. Next slide, please. So what the Magic Box is essentially is a self-backhauling wireless small cell. It's the first of its kind and the first real indoor deployment to be deployed in the hundreds of thousands in such a short period of time in the United States. And the key benefit and the key differentiation, I think that Airspan products deliver to the market, is the fact that if you see in the top left, what we're doing is not only are we solving the problem of indoor coverage and capacity at cell edge, but we're also improving the overall network macro network efficiency by moving the users at cell edge to cell center, which is in contrast to a repeater, which actually, or a signal booster, which kind of drains the capacity of the existing macro. And the reason that these kinds of solutions are extremely important in 5G and in 4G as it matures is that there's just not enough cell sites out there to meet the demand for the exponential demand of capacity. And what we bring to the table is a way of shifting the economics from cell sites to cell phone economics for those deployments. Next slide. So as I mentioned, it's a question of changing the deployment model and changing how the economics of the deployment are. And I think this graphic kind of puts it into perspective. On the left is we're moving from months of heavy truck rolls, site acquisition, site installation, zoning, et cetera, to a operation center which distributes boxes via FedEx. You plug them in, and within minutes you're up and running. And in the case of an outdoor deployment with a strand-mounted or a pole-mounted base station, that goes from minutes to perhaps maybe just under an hour. So it's really about addressing these issues that Zhan mentioned. Next. And what does this mean in terms of the I go back to the economics. It means that we're transferring a lot of the cost of deployment from operators to end users. Install, monthly rent, backhaul, and utilities are huge drivers of the overall total cost of ownership for operators. And we have done extensive studies in the U.S. and outside across the globe to quantify this benefit for our operator customers and new entrants as well. Next slide. So, and this gives you kind of an idea of the kind of portfolio of products that we offer. Zhan mentioned that there's CRAN, and 5G coming into play. As different bands become available, we have developed very, very enticing solutions both in millimeter wave and sub-6 gigahertz. 5G and R is right around the corner. And how we integrate with cloud and integrated backhaul in various deployment scenarios is going to be an exciting set of weapons in the arsenal of an operator to meet its capacity demand. Next slide, please. And this is just a highlight of some of our key success stories. We've deployed over 120,000 small cells with Reliance Jio, which was a completely greenfield operator in India. This operator went from 0 to 100 million subscribers in just 183 days in 6 months, which was a tremendous achievement, and really cemented, really disrupted the market in India. Next slide, please. And as I mentioned, with Sprint, we've had tremendous success with the Magic Box, over 260,000 cells deployed in just a year. GLOMO Award, Mobile Breakthrough Awards, and just a huge part of contributing to Sprint's improvement of their network quality over the past year, and it's been a very exciting time for us. Next slide. Just to show you in practical terms here, and this is a video actually, which you can find online. It's the IT manager of the Kansas City City Hall, and he's talking about, and I invite you to go and check this video out afterwards, after the webinar. But the point is that we were in a situation where this building had 0.1 to 1.7 megabits per second of available bandwidth on the download, 0.08 on the uplink. Really, just awful quality of experience. And by turning a Magic Box on, and this, in the first generation of the box, which was really even a rudimentary version compared to what we're deploying today, we were seeing 25x improvements in download speeds. And when comparing this to, Zhan mentioned a DAS system, the savings were incredible. And it just puts the whole thing into perspective in terms of the transformational benefits that operators can and spectrum holders can experience on their network. Next slide, please. And this puts into perspective the whole smorgasbord, if you will, of solutions that we offer. We offer both the backhaul and the access, and we split those two, and we integrate those two, and depending on the terrain or the horses for courses, if you will, that are appropriate for various applications. We have high power mini macro base stations that all in one, very compact, with go all the way to up to 20 watts, 2x2, 4x4 configurations, all the way to a few hundred milliwatts on the indoor for residential and enterprise that integrate the backhaul, all with all of these products using very sophisticated SON algorithms to make sure that this mass deployment of small cells is self-healing and self-optimizing at all times, and allows also for virtualization of the baseband in where needed in order to deliver some of those applications that Sean mentioned, both from LAA, a multi gigabit LTE, and improving latency for various vertical applications. We're a strong player in all of these fields, and recently have been funded by the UK government to develop a connected and autonomous vehicle platform running on our small cells. So we're excited about what's going on in the market, and not just the operator shipments that are increasing, but the private networks, the new verticals, and the new use cases which are coming to light in the 5G era. I think that's it from my side, but maybe next slide.
All right, thank you very much, Damiano. And now we're going to turn it over to Mr. Hongtao Zhan, who's CEO of SureCall. So take it away, Hong.
Thank you, Zhan. Next slide. So we're here talking about 5G and beyond. And not only 5G, we're going to talk a little bit about 6G. Just in case people are interested. Let me do an introduction of SureCall to begin with. SureCall is a company founded in 2001. We're headquartered in Fremont, California. We are a technology leader in the signal booster industry. Typically, we're first to market. We have numerous issued US patents, and the pending published patents. It's all focused on signal booster technology. It's either 4G or 5G. And we have won all kind of award. Inc. 5000 we're 3 years in a row. We also win top 100 fastest growing company in San Francisco area. 2 years in a row. We win the CES award back in 2017. So there's other smaller award as well. And this photo is when I was at the Inc. 5000 conference, Jump and the Smart. And next slide. And there's no secret, 5G is happening. I just borrowed this data from GSMA, and based on this data, I believe it's very much true. Half of the connection in the United States will be, by 2025, will be 5G. That's Walpole, almost 200 million connections. Globally, obviously, it will be slower and but way more connections. Next slide. So we've been working in in-building space for last 17 years, and that's where we're focused on today. When the 5G comes, what that means for the in-building, I think that most of you might know already. It's going to be very challenging. It's going to be very challenging. I'll give you some, technical numbers. Just to show how bad the signal will be when you go to 5G. At 30 gigahertz, can anybody have a guess how much of a signal at 30 gigahertz will last penetrating through a concrete wall? Does anybody here has a number? I'll give you the number. It's unbelievable high. It's 130 dB loss. 130 dB loss for that signal to penetrate through the wall, a concrete wall. Basically, nothing left. 130 dB. Basically, there's nothing left. So that's the challenge we're facing. That's when 5G comes. That's someone has to solve that problem, right? Because the in-building is where 80% of all the data traffic, for mobile happens. And it's a huge challenge. And come with this challenge is create a huge opportunity for companies like SureCall and Airspan, right? Obviously. We love it. We're up to the challenge, and we're doing a lot of work, pioneer work already on that. To be more specific, right? The 5G has lower band, middle band, high band, right? The higher band obviously is the most difficult ones. Lower band might be okay. We have all this years experience working on the lower band in-building coverage. We know plenty about that. The middle band is already getting tough. At a 3.5 gigahertz, typically in-building coverage, the solution get it become difficult already. It's durable, but it's difficult. In terms of provide full coverage, have a satisfied customer, all that. So the technology we're talking about for boosters, there are two things I was mentioned that's important. Moving from 4G to 5G, the booster has to go TDD, because the majority of the 5G system will be TDD, I believe. So the booster has to support TDD. It can be done. It's just going to cost something. Cost the end user something. Cost the manufacturing. R&Ds. But it's going to happen. It has to happen. Obviously, you have to support the millimeter wave. The high frequency. When you go to millimeter wave, everything gets tougher, right? It's more difficult to amplify signals, to get to the gain. It's going to be tough. And the only thing is you don't have to worry about a whole lot about interference and oscillation, because it's hard to get anything. So if you get some oscillation, interference, it might be a good thing. At least you got something. Next slide. Okay, here, just graphically, I'll show what kind of challenge we're facing, right? Moving forward, we're not talking. It's not linear, right? We're not talking about draw a linear line from 2G, 3G, 4G to 5G. It will be the building penetration, the in-building coverage problem. Well, I believe it'll be 100 times more challenging, 100 times worse on most of the band, and that's obvious, right? The most of the band, especially the band with the wider frequency range, it's on the 28 gigahertz or above. It's going to be very challenging. Next slide. So I think in Zhan's open presentation, he mentioned a lot of challenges facing the whole wireless industry, right? What about the backhaul? What about the regulatory? What about the zoning? What about the mutual host? What about the cost? What about the complexity, right? You put all this together, it's super complicated, right? It's tough. What if I give you a solution that does not need a backhaul, does not need a regulatory, there's no concern about zoning, there's no fiber, it can be neutral host if needed, and it's low cost, it's simple, and I think everybody will love it. And guess what? That signal booster happens. Signal booster does not require backhaul. There's no fiber, there's no DSL, no cable modem needed. And signal booster has already been approved by FCC and all the carriers in the United States, and is selling, in the orders, of close to 1 million, over last, 5 years, and deploying across the country. It's basically the enterprise, so even consumers can just buy one and install it themselves. I think the best part is that there's no need for backhaul, and I think that's huge. And the 5G obviously creates a golden opportunity for signal booster for the technology. SureCall is a 4G leader in this 4G technology leader in the space. We also are first mover in the 5G patentable technology, and it's an exciting time. I think next 5, 10, 20 years, we're going to be busy working on all the 5G related technology projects, and it's a very special period of time. Going to be fun. Next slide. So here, I finished my slides earlier, so I want to talk a little bit about the 6G. Anybody, panelists included, does anybody know what a 6G look like? Anybody? Any answer?
You got me there.
Yeah, I have no idea.
All right. So in our vision, the 6G, we think we know 6G. We think we know 6G. Obviously the speed will be 10 times higher, 100 times higher than 5G. And what is the underlying the technology to enable 6G, right? That's the question, right? My answer is, you heard it from me first, okay? My answer is, has to be laser. So, what that means is 10 years down the road, 20 years down the road, when you're walking on the street or inside the building or whatever, there will be a laser beam, invisible or not, follow you, provide you with all the super duper high data stream. That's, hey, that's just my guess. That's just when I do 5G training seminars, a lot of times people ask those questions, and I think that's the answer. And it's, my guess is just as good as anybody else. And this is for the fun of it, and but it's going to be fun. All right, with this, I finished my presentation, and thank you, Zhan. Thank you, everybody here.
All right, thanks very much for that, Hong and Damiano. Well, Damiano, you answered a few of them, but we got a number of questions here that are really just asking how the Magic Box works. I know there's some proprietary information there, but if maybe you could give us a little more color on how the backhaul and LTE access operates with that product.
Sure, absolutely. And I think we spoke about this at Mobile World Congress in Barcelona in detail, and there's a video on our website where we talk a little bit about that as well. But so if in case my explanation isn't clear now, you can also look at it there. But essentially, how does the Magic Box work? Inside the Magic Box, there are two components: the backhaul component and the access component. The backhaul component is based off of our iRelay solution, and that essentially is a very high spec UE. My cell phone, your cell phones are all 0 dBi antennas inside. They have very low MIMO, and they're mobile. Okay, the Magic Box is a stationary item with a very sophisticated antenna array with high gain and high order diversity MIMO. And what that does is that it ensures that at all times it's going to have a much better link budget than all of our phones in an in-building scenario, and the macro base station will always connect first to that UE inside the Magic Box. And what that does is that makes sure that the carrier's macro network is actually decongested, because it doesn't have all of these phones or these UEs trying to connect at poor modulation. And on the other side, what we have is the access, which is on a completely different frequency. So mostly when you see repeaters, what they do is they take the existing frequency and they just repeat it. Here, what we're doing is we're transforming it, right? We're taking the macros signal, and then we're transforming it onto a separate new dedicated small cell frequency. And what this means is that you're improving the efficiency of the macro network and solving the coverage and capacity in the indoor environment at the same time. So there's never a net drag on the macro network, rather an improvement overall of the entire network. There's a very interesting report from a company called Signals Ahead. It's some proprietary research, and they did a very extensive benchmarking. So if you have some time and money to spend, that's a very in-depth explanation of how the whole thing works. I don't know if that answers the question, or if I was allowed to speak about that report, but I don't know. That's my best answer.
All right. Thanks very much, Damiano and Hong. I see you've gotten a few questions here. This one kind of sets a baseline. It's a good question. I think this is a good opportunity for some market education. So what is the difference between a repeater and a signal booster?
Sure. I can definitely take that one. And by FCC definition, typically with a repeater, you shifted the frequency. So you shift the frequency to a much lower range and then coming back, something like that. Or don't come back. With the signal booster, you RF in, RF out. You don't change frequencies as we're doing right now. The beauty of the signal booster is it doesn't do anything about the signal. It doesn't, it basically is, strictly come in and the amplifier to get out. So all in the RF domain, not even touching the IF or digital domain. So it preserves, two good things happens. It preserves integrity of the signal to the maximum, and it's also simple, low cost, right? And remember, latency is a big concern in the 5G, right? Signal booster minimize the latency. So that's why it's what they say, simplicity is beautiful, right? So that's the signal booster. Repeater is more expensive, hard, bigger, all that. I'm hoping this answers the question.
Yeah, thank you, Hong. And I have a question for both of you. As you go through your product development cycles in support of immediate and more long-term 5G efforts, is it just about adding support for new frequencies, or is it more complex than that? Damiano, can you start us off?
Sorry, Zhan, you broke up there. Could you repeat the question?
Yeah, sorry about that. As you go through your product development cycles in support of near-term and more long-term 5G investments, is it just about adding support for new frequency bands, or is it more complicated than that?
It's more complicated than that. There is work that needs to be done on the baseband and the radio level. It's a 5G NR is a completely new radio standard. So there's a lot of work that goes into that. Also, developing radios in millimeter wave. It's for Airspan. It's something we've been doing for about 2 years now, but it's still different from simply spinning a variant of a product and increasing the channel size. It's particularly when you look at things like decreasing latency, adding MEC functionalities, and virtualizing the E node B to offer things like neutral host. There's a whole host of stuff and work that goes into that as well.
Okay, Hong, and then same question, and we've also got a few that have come in from the audience, specifically asking when you think signal boosters that are compatible with millimeter wave frequencies will be in market.
Sure. Okay, to answer the first question, I would say it's way more complicated. It's as I said, this is not going to be linear. It's not like you can draw a line from 2G, 3G, 4G experience and be done with it. No, it's not linear. This is a 10x, 100x more complicated, and there's so many things I do not have an answer. I'm talking about the technology-wise. Not engineers going to have to scramble to figure out creative solutions. I'm one of the engineers too. A lot of creative idea has to happen. It's not linear. No, definitely not. And it's a point of inflection. It's game changer. Everything will be different. It's almost like the PC from the PC world going to the mobile phone, cell phone world, right? 20 years ago, PC dominates everything, right? It's Windows, it's Intel. Is that going on forever? No, that's all. That's all history. Now it's the iPhone, it's the Samsung, it's the different platform, different everything. So I would predict this. The only thing can be predicted is changing. Everything will change. The existing player, a lot of them will be gone. And there will be a lot of more, new players, new names you probably never heard of will emerge, and the future technology will be amazing. No, I don't know what will be invented next year. I wish I know. Or 5 years down the road, SureCall is just happy to be in the game, happy to to be ready, invent the next big things. It's exciting. It's the big part is that nobody knows.
Damiano, we talked a lot about a Magic Box. Obviously, that's a very successful product for Airspan, but we have a comment here that I think you'll be able to address and perhaps highlight some of the other products in your portfolio. But the comments around backhaul, if we're talking about a 5G nationwide network, the comment is that you need fiber to offer 10G backhaul. So what are you guys doing in terms of fiber connected small cells?
Well, first, we've been developing small cells for a very long time, and we started with fiber. So it's and the small cells which we've deployed in Geo are all wireline backhaul. So those are hundreds of thousands of cells with fiber or Ethernet connection. So it's definitely something that we do across the portfolio of our products already today. With regards to delivering a gigabit of backhaul for enhanced mobile broadband to a small cell, I think that is something that will be available and doable as more spectrum becomes available in the market. I mean, in the United States, and sub 6 gigahertz, the only player with that kind of horsepower is Sprint. But more spectrum is coming up for auction. CBRS has a very wide channel size as well. If you've got 100 megahertz, you can offer a gigabit. So there's various markets across the globe that will have where operators will have the appropriate channel size, and you mentioned also carrier aggregation. So by way of carrier aggregating UE based on UE backhaul technology, a gigabit pipe is very, very doable, because as I mentioned earlier, there's a gigabit, there's a UE is what the relay is based off of. So I guess the point is that fiber is doable and it's available and off the shelf, but I wouldn't underestimate what wireless can do, especially as more spectrum becomes available.
Right. Hong, we've got a question here from you, and I'm going to put a little addendum on here. I think there might be some lingering confusion around how carriers and regulators regard signal boosters. So if you could maybe give a little background on that. And then the specific question we got here is, if a signal booster simply amplifies signal from the macro, won't it cause interference and decrease these SNR?
Well, that's fall under my expertise area. I can definitely answer that. So the signal booster, there is there's the old generation signal booster before 2014. So 2014 is a big year for a signal booster. Before that, 2014. The regulation on signal boosters, loose, and there are a lot of certified, FCC certified signal booster on the market, interference with power, all that, and it's a wide west. However, after 2014, FCC working together with all major wireless service provider and the signal booster industry, we work together, come up with a very strict technical spec, certification process to certify all the signal boosters. So all the signal booster today on the market, has to comply with that very strict, technical specs. And by doing so, it eliminates all the concern. The interference, the oscillation, all that is eliminated. Because what it does is it puts in a requirement, a mechanism, right? Any signal booster that's caused problems has to be shut down automatically right away. So FCC, the certification lab, actually tests that. So I give you a data, very convincing. Since 2014, there are probably close to 1 million signal booster being shipped in the United States. Out of this, 800,000 units also sold on the market and operating nationwide. I never heard any, interference cases. And it's a safe nowadays. It's not old days. Does that decrease the SNR? No, it's actually opposite. When it improves the SNR, typically, I would say 99% of the time, because that's what it's for, right? When you are in a building, you don't have a signal to begin with. You cannot make a call. You cannot get onto internet. How is your SNR? I think your SNR must be horrible, because you cannot. So with the signal booster, typically you will be able to make a call. You will be able to get online. You might be able to get to 10 megabits per second, or 20 megabits per second, whatever the, LTE speed, and your SNR will be improved dramatically. Basically the signal booster made up the, link budgets you lost because of the building, the wars, all that. And it does improve SNR dramatically, if you think about it, right? Remember, we're only talking about in-building solution, right? We're not addressing, outdoor coverage, right? And that's that's all, macro, that's all small cell, right? So overall, signal booster is a good thing. Even carrier recognize this, over time, they're happy with this now. I would actually predict this signal booster will be mainstream one day, maybe 5 years, who knows? Because there, for so many cases, there's no better solution. Signal booster is way better in terms of cost, deployments. I think the signal booster combined with the small cell will be the solution for the 5G problem for in-building. That's all I can say. I really don't see another mainstream solution. Not yet. Does that answer the question?
Yeah, I think so. And if not, we'll have the ability to follow up with the audience. But we're approaching the end of the hour here, so I want to get one last question to both of you. And first off, Hong, I'm glad you brought up 6G. That's certainly provocative, and well, I don't think it's prudent for us to spend any time speculating. I will point out that the ITU has established a working group to start considering what happens after 5G. What's the next step? So the best and the brightest are trying to answer that question for us. And this final question from David Franks, I like this question, and I'd like to hear your perspective on it. So the question is, what does 5G promise and deliver to the end user that justifies the cost to deploy it? In my inexpert opinion, 5G is about a lot more than selling SIM cards. You might see some incremental increases in ARPU as the cost of a subscription plan for a consumer goes up. But what this is really about, from my perspective, is enabling digital transformation for enterprises and industries. And I'll borrow a talking point from Nokia Bell Labs. Congratulations to them. I think they just won their 9th Nobel Prize last week. But Marcus Weldon says this in a lot of his presentations. He says, what the end game here is the automation of everything and the creation of time. So I realize that's fairly abstract, but I think it's kind of pointed. But Damiano, what's your perspective on that? What's 5G going to do that's going to justify the cost? Where's the ROI?
Yeah, I think you've taken the words right out of my mouth, in that it allows for, you know, the digital transformation of industries that previously didn't have access to these kinds of technologies. You know, we look at where, you know, the initial .com crash in 2000. You know, there were all these applications that were out there that were internet-based that just didn't have technology to back it up, right? And I really think that 5G is, and the various technologies that fall within the 5G umbrella are finally going to be able to enable these various use cases. You know, connected and autonomous vehicles is, you know, a big one, but, you know, industrial IoT and automation is another huge one. Massive sensor networks, which rely on a heavy 5G IoT network are also in there. And as we get closer and closer to the users with small cells and these kinds of architectures, more applications become possible. As you said, it's a question of physics. You know, what kind of latency can we deliver? You know, enhanced and virtual, augmented and virtual reality. All of these use cases now become very, very palpable and very, very deliverable. It's not about going from you know, an HD video to a 4K video because now you've got a lot of bandwidth. It's about many more applications that require very subtle layers within that. And then the other thing, I guess, is that you can now start to partition logical parts of your network via virtualization and slicing that will allow you to use your infrastructure in a far more flexible manner. And that, you know, that justifies the investment in this 5G infrastructure, because it can be used for more than just one application, and therefore the potential revenue streams that it can deliver the investor are you know, boundless.
All right, and Hong, what's your perspective on that? How's 5G going to you know, pay for itself over time? What's the application here?
Oh, sure. I'm glad you know, you asked me. And well, I have been in the industry for 20 years. You know, I watched the, you know, industry growing, you know, especially wireless telecom industry, you know, and I don't worry about that problem. I don't think that's a problem. You know, people will ask naturally, but that's not a problem, right? You're looking back, right? Where's the 56K modem? 56K modem was a pretty fancy stuff 20 years ago, you know, and you know, 10 years ago, even 10 years ago, right? LTE was, you know, was new, and people would ask why I would pay all that crazy amount of money just for all that extra, you know, bytes, right? And it's so expensive, too expensive. So, you know, two things will happen. Obviously, over time, the cost will go down, right? LTE was expensive, but over time, as everything scales up, the cost will go down dramatically, right? LTE now what? They have an unlimited plan, right? That's unthinkable 10 years ago or even 5 years ago. So the cost will go down. And on the other hand, I think this whole thing will start with the 1% always, right? You know, there's 1%, the Fortune 500 company, you know, some crazy applications, they have to have it. I don't know. Maybe it's a doctor remotely do the surgery, right? The cost is not an issue there. right? You're saving lives, and you're using the best doctor in the world, probably in New York, right? While you are in LA. So it will start slow. It will start, with the 1% of the people, application, the business, who has to have it. Then, who knows? You will have next generation, Mark Zuckerberg or someone invented a next generation application. My gosh, all of a sudden everybody goes crazy. It has to have a 3D, high definition television, video conferencing every day. I don't know, it's going to happen. It's going to happen. It's a historical trend. Nobody can stop it. It's going to happen. And I also predict it will create, next generation of the digital divider. It's like, either you have the 5G or you don't have the 5G. It will be two class. People who have access to 5G will have an advantage in terms of business, entertainment, everything. So it's one of those things, it's going to happen, not overnight. It might take 10 years to justify it, right? In 10 years time period, especially in the high-tech industry, a lot of things will happen, maybe, 15 years later, the 5G will be dirt cheap. Who knows, right? I think it will, actually. So that's my prediction. And hope that answers the question.
All right, gentlemen. Well, we have reached the end of our allotted time. To everybody that joined us, I want to thank you for your time, attention, and for the thoughtful questions. And Hong and Damiano, I appreciate you sharing your perspective.
Thank you, Sean.
Great.
Thank you, everybody.
Thank you.